Hey everybody, this is Larry. This is me going with Q4, weekly of the weekly contest 323, maximum number of points from grid queries. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So I have to come clean here. I am very known for writing code from scratch for my contest, but the one thing that I did have is I did copy paste some library that I had written previously into the code. That said, it didn't prove to be that much of an advantage because I have a couple of bugs that I had to fix. So I don't know if it actually saved me time, at least for this contest, maybe in the future. But I would say the first thing I would say with respect to the spoiler to that is that for this problem, you need to know union find. I'm not going to go over union find very much in this problem. You can think about it. You can look up spanning trees and minimum spanning trees and stuff like this. But this is a connected components problem as it evolves through time, and that is usually done with union find. And I to be honest, I really don't like these problems in some sense, because I think the way that they set up the queries make it sound like you should answer them one at a time, but really you pre-process all the queries together. So it's not an online type thing, but it's an offline, like, try to figure out what the situation is. Though for this particular problem, you can actually pre-calculate the answer for all possible things and then binary search on the query, which we'll talk about it later. So I guess in that sense you could do it, but I don't know that would be fast enough for this problem, but in theory. But that's basically the idea, is that, and let me bring up the paintbrush real quick, and okay, I guess I only have this image. Okay, right. So the idea, and I'm just gonna go for it really quick, is that basically I'm going to talk about pre-processing this, and this is thinking about connected components. Like I said, I'm not going to go over union find in this video, just because that's a whole that's a whole lecture. If you are taking algo in college, or if you took it, it's like the entire class, like just union find, maybe even 2 classes if you go more in depth into it. So I'm not going to go into it, at least not today. But the idea here is basically process all these in order, the entire matrix, right? What do I mean by that? What I mean by that is, okay, you look at the ones, and then you go, okay, ones, can you connect stuff? The answer is no. And then now the next number you say, so then here, and then there are a couple ways you could do it, but the way that I would explain it now is that, okay, now after we process the ones, how many space can one touch? Well, 1, right? Depending on how you want to say. And then now we process 2, because 2 is the next smallest number. Then in 2 you go, okay, the 2 connect to here, and the 2 connect to here, right? And then now you ask, from the upper left corner, how many numbers can you connect? And the answer is 3, right? And then now you connect the 3s, right? And then 3 is 5, right? And then next is 5. And then you could connect in different ways, but that has 8 numbers. And then finally 7, you have 9, right? So that's basically the idea behind this problem. I don't know that this is a great example to draw it out, but that's basically, so you build this array, and then basically for each query you could just binary search when the graph connects, because that's connected component stuff. For example, if the query is 3, then you just go 3, and then you look at the previous one, which is 2, because it has to be strictly greater than. But there's some, and there's another edge case about the starting node or whatever, but because then you could get 0 in the starting node. But that's basically the entire idea. I did it another way, but which I'll explain. But that's basically still the same core idea. I just handled the queries differently. And like I said, I had union find here. So I have this library pre-written, not gonna lie, and I pasted in, but I had a couple of bugs that I had to fix. One that I actually did not realize, I guess I should have, I thought I tested this, but basically apparently dot size is, is a keyword. So then, because I had this as size, and that size is one of those like Python functions. So then I had to debug that. That was silly. But yeah, let me go with my so let's assuming that this union find works, which now it should be, and it does union find things. Then let's go over the code. The code is that okay. So for each query, I basically put everything in an array, sorted by the value, meaning that if we query for a 3, this is a 3, and then the index, so that we can basically put the answer back into the right place later. So I sort by that, and this basically is what we're talking about. So G lookup, the grid lookup, basically for each value, we put it in a list of XY values, and then I sort all the distinct values, and yeah, I sort all the distinct values. I call the union. Construct a union find. I look up the I set up the answers, and then basically this is it, right? So for every edge that we process, we want to process the number of a query, right? So if this is a 3, then we process all the queries that are 3 or smaller first. So then we go, okay, well, we pop it. We go, okay, what is the size from the upper left corner? Assuming that it is bigger than the corners. Otherwise, this will return 1 because by itself, depending how you do it. But yeah, otherwise it's 0. And then after that, after processing the queries, we process the grid by basically what I said, right? So for each XY that has this value, we look up, down, left, right, and then we go, okay, if it's bigger than or equal to, then we connect them into one component. This is what the union find does. And then at the end, if we still have any items left, we parse them. That's pretty much it. This should also just be the size of the grid, to be honest, because that means that this is bigger than the biggest number. But I didn't want to prove it, and sadly that actually because I was like, we don't have to worry about it. It should be just slightly slower. But then it gave me my wrong answer because I had a typo here that gave me 5 wrong minutes. But otherwise, that's pretty much it. Like I said, union find. So I'm not gonna go with union find that deeply, assuming that each operation is O of 1 for the sake of argument. Yeah. So this is going to be Q log Q time. So this is O of Q log Q time and O of Q space, right? This is obviously O of R time C space, and this is O of R times C log R times C time. Just sorting all the unique keys because they could be all unique. Yeah, and everything else here is O of 1, right? So you can look through it slowly and show it to yourself. But yeah, everything else is O of 1. And obviously the answer is going to be O of Q space, and this is also O of R times C space. So in total, this is going to be O of Q log Q plus R C times log of RC or log RC time, and O of Q plus RC space. Yeah, so linear space, logarithmic time, or log linear. Is that what they say? I don't know. Anyway, yeah. And that's pretty much it. Let me know what you think. I'm going to show you I'm going to make the code smaller so you could see. So this is my union find code. I don't know. You may want to double check on some of stuff because apparently I had a bug on it already. But yeah, and this is basically the first half, including the important processing, and then the bottom just clean up. That's pretty much all I have for this one. Oops, what did I do? Let me know what you think. Stay good, and yeah, and you could watch me solve a live in contest now. There's 1,000 at most, so should be okay. But I'm not quite sure on that one, to be honest. It was a little bit slow. Xiaowu is back. Congrats, Xiaowu. Really slow on that one. 10 minutes. Okay. I didn't look at the problem yet, but it seems like a couple smart people got it already. So let's go. What are we doing? Maximum number of points from point where? So you have Q and queries. if query I is strictly greater than the cell you live in, then you get 1 at 2. Otherwise, you're not getting any points. Note that each query. Okay, what does that even mean? 5. You stop at top left, and then if it's strictly greater, then you can go any of the JSON ones. Okay. So basically for 5, it's a connected components thing, and it's a union find thing, I think. Okay, I mean this is doable. 3. Okay, so queries. Okay, fine. So for Q and query. A million things. We'll see if that's fast enough. This still need to be 1,000 though, but I don't know why they do it that way. It's just that I don't know. I'm kind of worried about Python. Because I mean, this is gonna be right, but it's just a little bit scary. That's all. So then now for the constants are terrible in this one, but we'll see. So for each value, we do, but we want to do the queries first. So yeah. This is so annoying. So because I'm not gonna lie, I have this code pre-written. I think I didn't fix this bug. If yeah, okay. If we people are so fast on this one actually. I mean I could get it, but so this is the value that we're processing. Okay, fine. While thing for QQ is greater than 0 and QQ 0 is less than V, then yeah, then we just go so then QQ of, because I don't even need to do it this way actually, to be honest. I can just and now so while the first left, and then answer of index is equal to, you find the size of 0 0 if grid of 0 0 is, if Q is greater than 0 0, then we do it, otherwise then it's just 0, which is also kind of really a bit weird, but it's fine. Okay, I think that part is good. Otherwise, kind of slow on this one, but I'm also trying to be careful. GLOOKUP, okay, fine. So for XY and GLOOKUP of V, for dx, dy and directions. If this new value is greater than y, then you have start union, I think I called it. Oh, I have to do a thing where otherwise then it's just, I have to do this one more time, I guess is the point. Which should be the entire way though, to be honest, but this should be fine. It's just look up. Okay, int object, I rename it or something. QQ is collection. Oh, jeez. Larry. Oh yeah, that's the other thing I forgot to check. Is that not index? Tick object not callable. Say what? Does that work? Okay, so it works, kind of. What does this mean? Tick object not callable. What does that mean? Which one is the tick object? Index? Did I mess that up? This is 2. Okay, so this is wrong, but why? I can't believe I'm debugging this. I wrote pre-wrote codes, I don't have to debug this. But that's size it. Maybe this is just weird. I don't know if it tries to overload something or something. Maybe. Okay, so there is some weird overloading thing that I did by accident. That's probably why. 1110 0 is right. 111's not so right. Tell me why. Just making sure that it is combining. It is combining. So why is it not combining? Okay. Is this 0 correct? Okay. So okay. Why am I so slow on this one? And also, why is it 1, 2, why 2, 2, 2, 2? Did I mess this up? Oh, jeez. I tried to put in a thing that fixed the bug and then it was silly. 883. Okay, now we have something to think about at least. Why? So the 6 makes sense. The 2 makes sense. The 8. Do I not do type breaking correctly? This is the 3. Okay, so does it process the 3? Do I not sort this correctly? Why is it parsing the 7 next? G lookup keys. 1, 2, 3, 5, 7, right? So why do I do something silly with we by accident? This should have been done already. I see. So I see. Because we needed 851. Okay. Now let's see if it times out because. Oh no. Where is this? Oh, this thing. I fixed the other places, but not that. That is a. This is you use a library and you still don't know how to do it. Still might time out, but that is a stupid mistake, though. Okay, that is stupid. I am a silly bee. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord, hit the bell, and yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.